Forward in
Okay, yes, we do skip chapter 7. We're going into chapter 8. Their warm-up was to simplify these fractions. Okay, number 1, what does that simplify to?
1/3.
How do you get that?
You divide by 3.
Good, you divide out their GCF. You divide out their common factor of 3, exactly. So I could really think of it this way too. I could think of it as I have 3 over 3 times 3. And as long as they have a common factor, we can divide those out, right? Or kind of like cancel them out. That's another way. You probably are like, why are you making it way more complicated? This is going to be how we do it with algebra. Okay, you got to find common factors and you can cancel. All right, what's my common factor in number 2? 8. Good. 8's my common factor, so it reduces to 1/2.
7.
GCF in 3? 7.
3 8.
Or again, I could look at this as 21 is 7 times 3. 56 is 7 times 8. I'm not doing like their prime factorization, right? They have a common factor of 7. 3/8. That's how we simplify fractions, right? We divide out their common factors. Okay. Here, 5. Should have gotten 3/13. Okay, so what I want you to write here is that you can cancel out common factors. Factors meaning we're multiplying. Factors. What we can't do, this is a non-example, is break up like a sum or a difference like this. Let's say I have 3 plus 5 over 3. That's the same as 8/3, right? 8/3. I can't do this. I can't cancel out because 3 is not a factor here. It's like a term, okay? And if this is being divided, this I'd have to heart if I wanted to break it up. It'd be 3 over 3 plus 5/3, okay? So you can't cancel next to plus or minus product, a sum or difference. Because obviously if you were to do that, you get 5, and 5 is not the same as 8/3, right? Okay. You can only cancel when they're factors, multiplication, not adding or subtracting. Got it? Okay. That's basically the rule, if you will, that you need to know with rational expressions. So rational means fraction, right? So if I have an expression, it just means I have some variables. So here's basically a screenshot of this being applied, what we can do with normal fractions. So see here you have that 15 over 65. And like I said, I know you don't think of it this way, but you could rewrite these as products and you could divide out common factors. Same thing with variables. So look at this one right here. I realize some people on the video can't see what I'm pointing. This one right here. This is 4 times x plus 3 in my numerator. In my denominator, x plus 3 times x plus 3. Do you agree that they have a common factor of x plus 3, both the numerator and denominator? Those would cancel. Okay. Now, some of them will be factored like that for you. There's some in your homework where it's like already broke up. However, a lot of the times you're going to get something like this, in which you have to look at what the factors are. We do that by factoring. So, factoring, first step, factor out the GCF. How many terms do I have left? 2. No perfect squares or perfect cubes, so that's really all I could do. Now, x squared, you don't really factor that down as x times x. But you can think of it here that I do have a common factor of x. So how did they get from here to here? They canceled out these common factors of x. Could I cancel these x's? No, because they're separated by addition. Only if they're being multiplied on top and bottom. You can only cancel out common factors. Okay? So that's basically like the 2 steps. I always say factor first, the F word, factor first, and save the fun part of canceling stuff out last. So that's the best part.
F word. None of that's fun.
Factor first, save the fun step for last. Okay, let's try. We're just gonna try 4 of these.
Can you like cancel those 2 out?
Okay, great question. Wesley said, could we just cancel these 2 out? What do you guys think?
No.
No, because they're separated by addition. What do we have to do first before we cancel?
Factor out.
Factor first. All right, up top, what can I factor out?
X.
X. Good. Now on bottom I have x squared, so there's really no way to obviously factor that. Then you have to think, okay, now that everything's fully factored, is there anything common that are factors, meaning multiplication? And I see I'm timesing by an x up here, and I'm timesing by 2 x's down here. So one of these x's would cancel out with one of these x's. Yes. So I'm left with x plus 5 over x. That was very similar to that one that they just had in the example. All right, let's look at number 2. Let me ask you this question.
Oh, I think I know what we got to do.
Could I cancel out these x's?
No.
No, factor first. Especially when your denominator has more than one term. All right, I'm looking at my top. Is there something I could factor out right away of those 3 terms?
Nope.
I'm literally just looking at my numerator right now. I'm ignoring my denominator. No, there's no GCF. How many terms do I have?
3.
3 with the 1 in front. Alrighty. That means this is going to factor into x and x. And then I got to find my 2 numbers that multiply to negative 15 and add to negative 2. I think I heard Wesley say negative 5 and 3.
Uh-huh.
Do we agree that works?
Uh-huh.
Okay, so that factors into x. Wesley agrees with himself. X minus 5, x plus 3.
Mm-hmm.
All right, now I'm looking at my denominator. Sometimes I'll even do this.
X plus 3.
Where did 15 go? Didn't even, Brayden was so excited he was going to answer that, and you just stole thunder because.
Ow! Way to go.
Gosh.
Okay.
Come on, talk for the rest of the hour.
Hold on, what'd you say, Sid? You had a question?
Where did the 15 go?
What?
We factored it.
But wouldn't the 15, it would be x minus 5, x plus, what?
We factored it. If you were to multiply this out, you'd get back to there.
I am brain farting.
We're factoring.
AC method.
Don't say that. It's not the AC
Yeah.
method.
Yeah.
There's a
that's
1
what
in
I'm
front.
thinking of.
1 in
Yeah.
front, so it's a trinomial, so you got to find your 2 numbers that multiply to
But then
C.
wouldn't we still have the 15, and it would be minus 15, and then you would factor by grouping?
Oh, that's the AC method. You could do it that way. It's way longer, but because there's a 1 in front, you can jump right to here because the only way you can multiply to x squared is x times x. Now, when we get down here, we will do that.
Okay.
You can do the AC method with this one. You'll still get to here. But I always tell students, like, guys, let's recognize some patterns. This takes a lot of the guessing and checking away for what the 2 trinomials could be, because the only way you can get to x squared is x times x. So it just saves yourself time.
Uh-huh.
All right, good. Glad we got that cleared up. Next one. Now I'm looking at my denominator and how that factors. First of all, anything I can factor out of those 2? Anything common?
No.
How many terms? 2. Perfect squares, perfect cubes. Braden, how does this one factor?
X minus 3, x plus 3.
Difference of squares.
Uh-huh.
Factor first. Everything's factored. Now here's the fun part. Is there anything common?
X plus
3.
X plus 3. You get to cancel those out.
Trees.
Where's the
X plus 3.
All right. Can I cancel these X's?
No.
No.
Nope. Don't be the person. Justin will do that.
Don't follow
I
Will.
feel Mr. Glassman had a poster that every time you do that, you got that.
Yeah. I've seen that
You
poster
should put that
before.
back up.
I'm good. Thank you.
Something but
This next one's difficult.
Okay. Well, just take it step by step. So just ignore your denominator for right now. Just ignore that. And then factor the top. So the first question I ask myself every time I'm factoring is there anything I can factor out right away?
No.
2
Wait, oh,
and an
yeah.
x.
Oh. Did not know that.
And then I'm left with x plus 5. Those are not perfect squares or perfect cubes, so that's all you can do to factor that. Okay, don't make those ones harder than they are. This one I have to do the AC method, okay? Obviously, there's nothing you could factor out first. So I'm just going to kind of come off to like the side over here. So you got to do 3 times 5, which is 15. And then find your two numbers that multiply to 15 and add to 16. So Sid, the reason why we have to do this is because there's a number right here. Because it could be this, it could be this.
So when there's a 1, is it okay that you do this way, the AC method?
Yeah, you can. It just takes a long time.
Okay.
So I wouldn't recommend.
That's what I'm
But
doing.
it works. All right, so that's obviously just 1 and 15, right? That's the only way that those would add to 16. So now we got to do the 3 terms. Doesn't matter what order you put them in. But I'm just splitting up 16x into those two numbers, 1x and 15x. And now we factor by grouping. So out of my first group, I could just factor out an x, and I'd be left with 3x plus 1. So then I kind of ask myself, what could I factor out of my, oops, that should be a 5, sorry. I was like, this doesn't make sense. What could I factor out of my second group to be left with 3x plus 1? Positive 5. So I like to write plus 5 there. Factor out the 3x plus 1s, and that'd leave me with x plus 5. Now that you guys have done a lot of like multiplying binomials too, you should just quick like check in your head. Like if I were to multiply this out, 3x squared plus 15 plus 1, oh yep, that'd give you plus 16 plus 5. Okay, yep, that does work. You're just undoing multiplication when you're factoring. It doesn't matter what order you put these in either. We can multiply in any order, right? Factor first. Then we get to the fun part. Anything common?
Yeah,
X
plus
plus
5.
X plus 5. And again, put parentheses around so you can see too that those, I know they're separated by like addition, the x's and the 5's, but it's a factor of x plus 5, so it's different. That would be your final answer. Okay, now this one looks scary, but the top's already factored for us. Oops. The top is actually already like broke up into factors for us.
Oh, they're scary ones from back.
Okay, that's nice. What about the bottom? Let's see. What about the bottom? Well, it looks like they factored out a 6x, but I have a trinomial with a 1 in front. So I got to ask myself, are there two numbers that multiply to negative 20 and add to 1?
5 and negative 4.
No.
5 and negative 4, those would indeed multiply to negative 20 and add to 1. All right, so we have to finish factoring that. Oops. And then as I mentioned, my top is already factored. Another thing I tell students too is usually you're going to have something that cancels out. So if you need a little hint, if you're looking at your numerator, you're like, oh, I see like an x plus 2 and x minus 4, that might be a little hint that there's one of those in your denominator. Not always, but usually that's how a lot of these problems work out. Okay. Who can tell me one thing that's common? X minus 4. Good. Michael noticed a little bit more challenging one. They also have a common factor of x. Do we see that?
Huh?
This one has x times x, and this one has an x.
Oh.
So we could get rid of one of the x's. Nice job, Michael. That's sometimes hard for students to recognize. We can get rid of one of the x's in the numerator. Now, folks, when you're writing your final answer, you can just keep it in this factored form. Okay? You don't have to distribute the 6 through. You don't have to distribute the x through. You should make sure that's what the back of your textbooks do, but I'm a-okay with you leaving it in this factored form. Let's quick take a look at the textbook ones. Yeah, they leave it in the factored form. Okay, good. Good. All right, that's straight up simplifying. Easy enough, right? It's just a lot of factoring. Let's see if you guys just remember how to multiply and divide just normal fractions. So the first 4, I want you to find the product, which means multiply. The next 4, I want you to find the quotient, which means divide. Okay, I'll give you about 1 minute to try those. No calculator. Don't confuse these with proportions.
Are we just supposed to do the top one?
Both.
Yeah, watch the. Oh.
Okay. In general, raise your hand for this. In general, how do we multiply fractions? Like, what's like kind of like the rule, if you will, or the math?
Multiply from.
Multiply straight across, right? Not cross multiply. That's proportional. We multiply the numerators and we multiply the denominators. So here we get 6/20ths, and then if you reduce that, you get 3/10. Out of curiosity, did anybody simplify before they multiplied?
No. Wait, what? You can do that?
Yeah, I'll show you in a second.
Oh, you can do like the 2 and the 4.
Okay, yes. So since they're all factors, what you could do here is look at the numerator and denominator and see are there any common factors. So Wesley's right, like 2 and 4, you change that to a 2. Those have a common factor of 2, and then you would get 3/10 right away. Anybody do it that way? That's how I multiply fractions, because then it makes your life easier in the end. You kind of do all the simplifying first. And that's what we're going to do too. So you're going to look at common factors. Let's look at number 2. Common factors, 5 and 10, right? And then what about 2 and 8? I could get 3/4 right away,
That's cool.
right? Okay, if you didn't do it that way for now, it's okay. Just wanted to show you that, this obviously works with fractions because they're all factors. All right, common factors in this one. Again, the 2 and the 8. Oh, 5 and 15. Nice. That'd be 1 and 3. Did you guys get 1/12 for that one?
Yeah.
All right, now, if you just have a plain old number, you can think of that as fraction. That's really just a 2 over 1. So I do see common factors with the 2 and the 6. 1/3.
That's what I got.
Okay, good. All right, what's kind of our rule for division with fractions, Brayden?
Multiply by the reciprocal.
Yeah, have you guys ever heard keep, change, flip?
The second and multiply.
Keep the first,
Change the sign.
change the sign, flip. Keep, change, flip. Keep, change, flip. And then it just becomes a multiplication problem. Keep, change, flip. And that is exactly like the 4 we were just doing. And guys, that's just the same math. Like, if you divide something by 2, that's the same as timesing it by a half, right? You're dividing it, taking half of it. You're also timesing it by half. Okay, and then again, I personally like to do that thing where I can simplify before. Let me ask you this question. Could I simplify these 3s, cancel those 3s?
No.
No, they're both in the numerator. All right, so I could not do that. That one's 9/8.
Yep.
Already simplified. This one, you could cancel these 2s. That one, you should get 3/5.
That's what I got.
Okay. Here. Divide those by 7. 25/9.
Yep.
Good. Here, nothing I can cancel. 1/12.
Yep.
Okay. So that's the exact same rules, if you will. Rules. Or way that we're going to do multiplication and division with variables, with rational expressions. All right, here's kind of just like the basic rule for multiplying. You got to multiply the numerators, multiply the denominators. If it's a division problem, change to a multiplication problem. You know how to do multiplications? You can do divisions. Keep, change, flip. Okay? All right, so let's try one. Now, just like with simplifying, before we get carried away with trying to distribute out all of this, we're going to factor first. Factor first. That's our model for the day.
You should write it on the board.
First.
Can there like
write it in
all
your
the
brain.
assignments be like 5 questions long?
All right. So I'm gonna start with just this first fraction. So I'm gonna ignore this whole thing, and I could get 2 rectangles up here if I want, but I'm gonna ignore that whole second fraction, and I'm just gonna start with factoring the upper left-hand corner. All right. So in my numerator of my first fraction, what could I factor out of those 2? 4. That's it. 4. 2x minus 5. I have 2 terms left, but those are not perfect squares or perfect cubes. Factored. Done. All right, let's stay with that same fraction. Ooh, nothing I can factor out right away. A trinomial with the 1 in front.
5 and 7.
Which one has to be positive?
5, 7,
7, because I have to add 2. Positive 2. Good. See how that's just way quicker than doing AC method when there's a 1 in front.
Yeah.
All right, second fraction, same thing. Factor first. All right, ooh, another trinomial with the 1 in front.
Negative 5, negative 2.
Negative 5 and negative 2. John Willis. Oh, JT's here.
Not time to show up.
JT.
It
Oh,
is.
Justin.
Don't kill him.
Wow. Skip a class. Yeah.
Wow.
You're
This is why I'm changing weird.
We see how
Oh,
it
you
is.
shut up.
I'm going to get you an out packet here, Justin. We also pass back in fast.
Oh boy.
You're on 3 days, Justin.
Huh?
You're on 3 days.
Huh? Well, that's supposed to be on 3 days.
Yeah, for your real driving, it takes more than 3 days.
You know what? No one can put it back together.
Okay, this bottom right one's kind of weird. So first I need to factor out what?
4.
4. And then I'm actually left with difference of squares.
Oh.
Don't forget about that.
My bad.
So that would be 4 times what?
X plus 2.
Plus 2,
Minus 2.
x minus 2. So if it helps you to like do that and kind of like ignore this. Well, I don't know if you want to draw a line. Wait. Don't get cancel happy yet.
Why?
Wait for us. If you want to just like scribble this out so you know like this is my denominator now. All right. So now that we've factored everything, just like before, when I was doing this with fractions, you can cancel anything that's common in the numerator and denominator, whether they're on top of each other or kitty corner from each other. As long as one factors in the numerator and one factors in the denominator, you can cancel them. So what's one thing I can cancel?
Oh, the X
That's a lot.
minus 2.
X minus 2. So I can cancel those. One's in the numerator, one's in the denominator, right?
And then the X minus 5.
X minus 5, 1 in the denominator, 1 in the numerator.
It's a
What
4.
else? 4s cancel. Good, guys. Anything
That's
else?
it. That's it.
That's it. So up top, all I'm left with is 2x minus 5. You don't really need parentheses around that since that's the only thing you're left with. On bottom, don't multiply these out. You can just leave them factored. X plus 7 times x plus 2. That's all it is. Here's how students make it really hard, is they try to multiply this all together first, and then they're left with a mess that they have to factor. I'm like, don't do that. Don't do
You
that.
don't have to
Factor
multiply the bottom
first. Factor
Wait,
first.
didn't
Nope,
you
I
just-
said you can keep them in factored form.
Oh, sweet.
Yep.
Didn't you use like synthetic division? Is not like really easy.
No.
We're not
that's
dividing by a
yeah.
polynomial anymore. These are
That's
rational
back.
expressions now.
Um,
We're dividing by like, oh, you're saying with like these two?
yeah, like once you cross multiply, like if you just multiply the top row, it'd be like x to the 4th when you use synthetic division.
You could do synthetic division. Synthetic division only works when your divisor's degree 1.
Oh, yeah.
So this we'd have to do polynomial one, which you don't want to do that.
No, I don't
I'm gonna give you ones that like factor.
Ooh.
Okay.
So we should switch that side.
Okay, look at this one. I have this rational expression times another rational expression to the negative first power.
Yes, you got it.
I
You
like
switch
Wesley's idea.
it.
Now remember, this isn't a keep change flip. This is still a multiplication problem. I just see a negative exponent. So I'm going to go ahead with my knowledge of exponents. I'm going to go ahead and flip that, and it's going to come to the positive first. And I would get this. Do I need to flip the left fraction?
No.
No, that one was not raised to that power. That stays this. Okay. That would be a beautiful first step.
Would you, for that one, would you do then the X minus 3x plus 3?
Okay, close.
Or, well, 3
Yes.
minus X.
Now, this one's weird because it looks like it should be a difference of squares, but it's technically not right now. You could do it this way. This technically isn't wrong. If anyone's thinking like, oh, it'd factor like that, you're not wrong. But what we're going to do, and you can do this as long as you keep it factored out, is we're going to factor out a -1. We're going to factor out a -1 of this, and that's going to become -9 plus x squared. Agreed?
Yep.
Okay, and that's the same as x squared minus 9. Agreed?
Uh-huh.
And so then that would factor into x plus 3x minus 3. That's what you want to do in that case. So it's kind of like a little algebra trick, if you will. And we do it a lot in like calculus sometimes we're like, ooh, we have the right terms, but they're all the wrong sign. What can I do? Oh, I can factor out a -1 of everything and then flip my sign. All right, so if you want to, you can kind of just like scribble out these parts. Oops. Now this is my fully factored. I have -1, x plus 3, x minus 3. That's my fully factored of that numerator. Okay, that's what I want to do one like that in class. Those are kind of tough. All right, now I'm looking at the denominator of my first fraction. Ooh, trinomial with a 1 in front.
X plus
3 minus 7.
minus plus 3.
Plus 3 minus 7, that would work.
Uh-huh.
Okay, ooh, both of these we have to do AC method. You guys want to make a deal? I'll do the top one.
And Nick will do the bottom.
And you guys all do the bottom one. And then we'll just share our answers.
Confused.
You know what? I want everybody to try the AC method once on their own, though. You
Yeah.
guys try this one. I'll do the top quick.
I guess.
You should have some room on your paper somewhere.
You go, Wesley. No.
See if you can get there. Factoring's important
You have to do it in pre-calc.
all the time. You will literally factor for the rest of your life. That's fine. I decided I'm kind of done begging people to take classes. It's exhausting. Do what you want.
I'm not. It's on my schedule.
For the top. The lowest time takes that.
Ooh, I got it.
Michael, I know you learned a different way to factor, so if we're confusing you, I apologize.
Wait,
No, he just does it with his crack.
that's what I got.
can't do this like
Yeah, right.
I did not. Come on, Brad.
All right, I got, for the numerator, I got 2x minus 1, x minus 7. So you can go ahead and write that in. Try the bottom.
2x minus 1, 2x, x plus 7.
I have 2x plus 1.
Yeah, I got something different.
2x plus 1, x
Oh.
plus 3.
You're repeating the top. You're repeating me.
It's 2x plus 1, x plus 3 for the bottom.
2x plus 1,
That's what I got.
x plus 3.
Uh-huh. I think so.
Yep, that's right.
I think so. So, like, can you cancel, like, that one and that one and that one and that one?
You can only cancel out, so like I couldn't do this, this, and this.
Oh,
It would just be like either just these two or just those two.
okay.
Yeah, good question.
I'm very smart.
All right, so Wesley, notice we have a lot of x plus 3s. Now, you can only cancel out like one factor at a time, so I'd probably do like this one and this one. They're right on top of each other. Because, guys, and you understand the reason why those cancel out, right? What's x plus 3 over x plus 2 the same as?
1.
It's the same as 1, so you're really just multiplying by a big old 1. Okay, that's why. That's like
this one.
mathematically why you can do that. What else is common?
X minus 7s.
X minus 7. Is there one on top and one on bottom?
Uh-huh.
Yeah. Ooh, these are close. Can I cancel them?
No.
No, they're not the same. Same with the, obviously, the x minus 3 and x plus 3. All right, so final answer would be,
X minus 3.
don't forget about the negative. Negative
2x
x minus 3, 2x minus 1, all over 2x plus 1, x plus 3. Don't multiply those out. Just leave your answer like that.
Got it.
Okay. So if you can do multiplication,
We can do
you can do division, because you just got to change it to times
Oh,
reciprocal.
no.
Times reciprocal. Okay? Now, this one, people sometimes make these ones, like number 1, harder than they are when there's not like really much you can factor. Okay, this is kind of just more of a exponent rule type of situation. But before we get there, like I said, we know how we divide by fractions is we keep, change, flip. So there's really not much like factoring we could do here. If you wanted to write out c squared as c times d. If you wanted to do that, you could. And write out 10 as 5 times 2 times n times k times 8. You can, but you guys know what common factors we have. So let's start with numbers. So 5 and 10, those have a common factor of 5, right? 3 and 6,
2.
common factor of 3. Okay,
And C too.
Top and the bottom both have c squares. Those are all gone. And if you want to like scribble like this, you can clearly see what's like left. Those are all gone. Good. What about the d's?
Just one.
Just one where? Up top or on bottom?
Up top.
Yep, there's 2 here, 1 down here, so you can cancel out 1 and 1.
And
And then just one m.
M to the 4th.
1m, good. 1m down here would be m to the 4th.
And there's no K.
No k. So this ends up being 2 times 2 times k squared times d. So 4dk squared over
K squared.
m to the 4th. That's it.
Cool.
This is a good unit.
It's a lot easier doing it that way versus multiplying it all together and then having to try to simplify it, right?
Is it easier than this or harder?
It gets harder than this.
Mm.
Because
Dividing,
let me ask you this: what's harder, multiplying and dividing fractions or adding or subtracting fractions? Because you got to make what? Common denominators. We'll get there. Don't worry. Not today.
It'll be.
All right, let's try one more division. Keep.
Change, flip.
Change, flip. Don't forget to actually flip it. Some people just straight up change it to multiplication. I was like, well, now I just created a new problem. They forget to flip it. My first fraction, there's not really much I can factor, right? 3x plus 7, not much I can do there. All right, top right, I have a trinomial. That one's pretty easy. X plus 7, x minus 1. On bottom, what's common?
8.
8x. And I'd be left with x minus 1. Technically, 1's a perfect square, but the x is not a perfect square, so we're all factored here. All right, so what cancels here are the x plus 1's, the x plus 7's. So this one would just be 3 over 8x. Yep. All right, now the last one looks really scary, right?
Yeah.
This is something called a complex fraction. Have you guys heard of that before?
No.
Yeah.
No. Well, think about what the word complex means in real life. It means like it's pretty
Difficult.
difficult, or there's like a lot to it, right? Complex. What a complex fraction is when you have one fraction within another fraction.
Can you just like split it off and then make it into a division problem?
Exactly. This is really just a glorified division problem. This says you have 4x over x plus 6. Every fraction is just a division problem. 4x over x plus 6 divided by x squared minus 3x over x squared plus 3x minus 18. Everybody okay with that? This is really just division. That's the math. Really just the same as dividing. And now we can change flip. Keep, change, flip. And this one's very similar to the one we just did, so I'm going to quickly factor it since we're running a long time. See why it's important to know how to factor? You don't know how to factor, this would be a pretty tough unit for you. All right, now that I've done the fun part for you, sorry, I did all the factoring for you. What can we cancel?
Minus x minus 3.
X minus 3 is good.
And x plus 6.
X plus 6, what else?
X.
X. Can you guys believe that this whole fraction reduces to just 4?
Yeah.
Isn't that weird?
Yes.
Let's just do the math.
Surely.
Okay, hold on, one last thing. And we still have 4 minutes. One last thing. On some of these problems, they might ask you to find the domain. The domain. Okay, so let's just talk about this. So the thing that's tricky with the rational fractions, is we know we can't divide by 0, right? So what you have to look at is you have to look at any time you were dividing by 0. So you have to look at your divisors right here. Ooh, technically we'd have to look at this whole thing. We'd have to look at this, and we'd have to look at when this is 0 too, because this we were dividing by this whole thing. All right, so let's set these each equal to 0. Let's start with the x plus 6. So that can't be 0, right? And you can do this if you want. This can't be 0. X can't be negative 6. And neither of these can be 0. Now you guys already factored them right here. So x times x minus 3, that can't be 0, and neither can the x plus 6. X minus 3, you're going to notice we're going to get a lot of repeat ones here. So here x can't be just straight up 0 from that. X can't be 3. And we get negative 6 and 3 again from there. So my domain here, x just cannot be negative 6, 0, and 3. So again, you just have to check any of the like divisors and a complex fraction. Technically, my divisor was that whole part I circled in blue, so none of that could be 0.
Okay.
All right. That's all. And there's only one assignment that goes with this lesson.
Yay!
It's a textbook assignment.
How long is it?
It's actually not bad. I was looking at it, the list of problems.
Not bad.
How long?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12
That's
problems.
not
I think I can finish that one.
Yeah. I think we could all finish that one. Justin, I wasn't.
Maybe I'll finish it this time. I see my
What?
I had this.